This is section 10.5, and we're going to talk about some more angle relationships in circles. We're going to go a few things that are inside and a few that are outside of the circles. So first on your theorem card, we've got 4 different theorems today. So I'm just going to talk through them one at a time here. So the first one, we've got a vertex on the circle. So we've got these 2 angles kind of like this, and we're talking like, here's your first angle right there using both of the lines, and then here's your second angle. And they're kind of like having an inscribed angle actually. So when a tangent and a chord meet, then each angle is half of their arc. So this angle 1 is half of this arc AB, and this angle 2 is half of this major arc BCA. So the example I have over here is I have 192 on this side, and then to figure out this side, we would just do 360 minus the 192. That'll get me this one. So that was 168. And then to find degrees, and then to find this angle measure, all we have to do is just cut it in half. And to find this angle measure, all we do is just cut that in half. So that's kind of the math I'm doing there. And there's kind of 2 checks for that. So your 2 angles out here have to add up to 360, and the 2 angles you make there actually have to add up to 180 because they make a straight line. So you've got a couple of different ways to check it, but still kind of the same as inscribed angles. The arcs are twice as big as the angle measure. Next up, we've got when a vertex is in the circle. So here I've got 2 chords, and they're crossing each other in the circle, not at the center. Squeeze that in here. We're not at the center. If we were at the center, we would be doing central angle stuff, and those angles are equal to the arcs. This one's not at the center, but they just cross somewhere in the circle. So if 2 chords intersect inside the circle, then this angle 1 right here is half of the 2 arcs A and B. And what I kind of tell kids is, I'm gonna do this in pencil, is I say, if this is the angle you're looking for, go from where they intersect and draw straight through it out to the chord or out to the arc, and then go the other way. Those 2 arcs that you hit, those are the ones that get added up. So angle 2, if I were to do that, I would draw through angle 2, I'd be pointing to BC, and I'd be pointing to AD. Those would be the 2 arcs for angle 2. So it's half of those 2 arcs added up. And then the example I have for you here is if we were going to find angle E right there, so that's where they intersect, I would just use arc 109 and then arc 45, add those together, divide it in half. Next up, we've got what if the vertex is outside of the circle? So it's outside the circle, and this 1 is like in that corner. It's kind of hard to print it, but we're talking about finding that angle right there. So that angle is equal to half of, and it will be the big arc that's on the outside minus the small arc on the inside. So it's 1/2 big minus small. You'll hear me say that quite a bit too. So this is where a secant and a tangent come together. Vertex is on the outside, and the angle in the corner is equal to half of big minus small. So the example here is 56. They're arrowing it in there, if you can see that. And so I put a little X on the small arc that's inside, and the 160 is the big arc that's on the outside. What you do have to kind of ignore, or you have to get your eye to not look at, is anything that's outside of your angle. So wherever your angle is happening, you can only look at the 2 arcs that are in there, the big one and the small one. You can't use anything that's outside of your angle. So our 56 is equal to 1/2 and then 160 minus X. And then we can just solve this. The fast way to do it is to actually multiply by 2, because that gets rid of that. So I got 112 equals 160 minus X. And then you'd probably minus the 160. That's my shopping list. But what's going to happen, what you're not going to like, is it's going to come out to be negative. So 112 minus 160 actually gives us negative 48. But if you look, also your X is negative. So all we have to do is just get rid of that negative on both sides. So my X is 45. Another one where the vertex is on the outside. Idea is still the same. Here are 2 tangents meeting on the outside. So they literally take care of the entire circle. There's not a chunk that gets left out like this last one. So that is kind of like that ice cream cone example we used in 10.1. So these 2 tangents are holding the entire circle. You have a portion that is outside, well, I should say a portion that is big and then a portion that is small. And the formula, really, the idea stays the same. This angle out here, the one on the outside, is equal to half of, and then it is big minus small again. And the example here is angle Q, so this tiny little angle right in there, is 1/2 of 313, which is this huge arc, minus x, which is this little arc. And so I need one more number for this picture to work. A whole circle is 360. So 360 minus the 313 tells me that where x is, that is 47. So in this example, in this type, you're going to be using 360 minus quite a bit. So you're going to do 360 minus your big arc to find your little one, or vice versa. You could minus your little one to find your big one. So now we know that x is 47. So angle Q is just 1/2 of 313 minus 47. And I get 133 degrees. One more property. It's the exact same idea. Vertex is outside of the circle again. And this angle has two secants meeting. So again, that whole idea, tear this in half, is you cannot look at anything that is outside of your angle. So if you kind of use paper like this and narrow down your angle, you only get to look at the arcs that are inside of your angle that are cut off. So you don't get to look out there and you don't get to look down here. So if you use little papers, go on the edges of your angle, these are the only two arcs you get to use. And the idea is the same. The angle on the outside is going to equal 1/2 of, it's always going to be big minus small. The example that I have over here, I have a 56, that's my small arc. I have a 140, that's my big, 66, sorry, not 56. That's my big arc. So my angle L, which is this one out here, this tiny little corner, is equal to 1/2 of 140 minus 66. So 37 degrees. So those are your theorems for today. These three are all the same. It's all 1/2 big minus small. The difference is just where or how the circle gets cut or not cut. But the theorem is the same each time. This one where they meet on the inside, make sure that you're doing 1/2 of and then draw through the angle, hit an arc, go back the other way, hit the other one. You're going to add those up. So let's try a couple. First one says, let's find the measure of angle 1. So this would be an angle that is on the circle. So it's essentially an inscribed angle. And remember that inscribed angles are 1/2 of their arcs. So if the arc is 210, for us to go back in, we would just cut that in half. So 210 divided by 2 means that angle 1 is 105 degrees. Next one says arc RT. This is the T. And then we always want to go the smallest distance possible. So we're talking about this RT right here. That I think says 96. It's really bad, but I think it's 96. We'll go with 96. So if that angle is 96, then that means that this arc is 2 times that. So that's 196. And then this we could do this a couple different ways. So now that I have that arc, this circle is 360. So I could minus the 196, and that would leave me with 164. That would be my arc. Another way I could do it is this is 96. So if I do 180 minus 96, this angle right here is 84. And then I would just double that to get 164. So you kind of have a couple of options depending on what, I don't know, what kind of seems easiest or what comes to your mind first, either using the whole circle with 360 or the straight line with 180. Next up, this is the one where they cross in the circle. So we're talking about this one. So we're going to draw straight through and we're going to find the two arcs we're going to use. So X is what I'm looking for. I'm going to draw straight through X. I'm going to go to the two arcs. So X, the thing in the middle, equals 1/2, and then the two arcs added up. So 156 and 130. So 0.5 times 156 plus 130 gives me 143. Couple more. These ones, or this one has the vertex on the outside of the circle. In all of those theorems, anytime they're on the outside, it's always 1/2 big minus small. So whatever's on the outside, for us that happens to be an X, it is 1/2 big arc, 178, minus small arc, 76. Remember, you can't use this because it's outside of your angle edge. So wherever your angles are, you're going to use the two arcs that are inside of there. So I've got 178 minus 76, which gives me 51. This one, even though these lines are going outside of the circle, the angle is inside the circle. So that means we're looking at this formula. So we're talking about where is the vertex of the angle. Is it inside the circle or outside? So this one's inside. So if I were to draw through the 102, I would actually point to these two arcs. Not helpful because they don't have anything. But we could figure out this angle because these two have to add up to 180 to make a straight line. So 180, what did I say that was? I think 102. So 180 minus 102 gives us 78 for right there. And now I can go this way instead. So 78 goes with these two. 78 is the angle in the middle. It's half of the two arcs added up. So 95, oops, and y. The fastest way is to times by 2. Also, it means you probably won't have a fraction then because you're getting rid of the fraction right away. So 78 times 2, oops, I did not that, 156. And then we're going to subtract 95 over for 61. Last one, the corner, the vertex is outside of the circle. So I'm doing one of these three. We're outside. Doesn't really matter which one you pick because they're all the same. 1/2 big minus small, big minus small. So the angle on the outside, the 26, is 1/2 big arc, y, minus small arc, 30, times by 2, and then add 30 to both sides. And those are your theorems for 10.5. Decide if your vertex is inside the circle or if you are outside the circle.